Okay, so at this point in time, you should probably know how to read elements on the periodic table, but we're going to go ahead and quickly review that right now. So, first of all, the periodic table was originally developed by Dmitry Mendeleev, some Russian dude, and he had initially organized all of the elements by order of increasing atomic mass. This would later be fixed, because some elements will go from one to the other, and you'll see a decrease in the atomic mass, and then it'll pick back up. But this was later changed to being organized by atomic number. Now, this is what your typical block on the periodic table looks like. Here we have this top number, which is known as the atomic number. You should already know that the atomic number represents the number of protons that an element has. So for this element right here, you could say that it has 1 proton. Below the atomic number, you can see the element symbol, which is simply the symbol that is used to denote the element itself. Make sure that whenever you're copying down element symbols, you copy them in the format on the periodic table. So for something like hydrogen, it's always a capital H. If you're working with something like calcium, it should always be capital C, lowercase a, and there will be no deviations from this. Below the symbol, you'll obviously see the name of the element itself. For most of your elements, it's going to be a similar sounding name to whatever the symbol is, but you'll see some exceptions, like potassium being K, sodium being Na, and iron being Fe. And then lastly, right below the name, you'll see the atomic mass / weight, which is simply the average mass of an element. Remember that in order to calculate the atomic mass or the atomic weight, you take the abundance and the mass of all the isotopes of an element, and you take a weighted average of it. This should all be information that you're pretty clear with, so we can just go ahead and move on really quickly. Now, in terms of the periodic table itself, it's organized into 2 things, periods and groups. First, we're going to talk about the groups, which are the vertical columns on the periodic table, and you'll see 18 total. Now, the reason why the periodic table is organized into these groups is because when you have elements in the same exact column or in the same exact group, they'll all have similar properties to one another. Now, we can actually split up our groups into 2 different sets, the A groups and the B groups. The A groups are going to be groups 1 through 2 and 13 through 18. We're going to abbreviate those as groups 1A through 8A. Now, the nice thing about remembering these is when you actually talk about the A block groups, group 1 obviously translates to being group 1A, group 2 obviously translates to being 2A, and then when you get to the 13 through 18, group 13 is going to be 3A. You can notice that they both end in the number 3. Group 14 will be 4A. You can obviously see the same pattern, and group 15 will be 5A, so on and so forth. So it really shouldn't be that difficult to memorize all of these. Now, the other set of groups are the B groups. So groups 3 through 12 will be known as groups 3B through 2B. The nice thing about these is very similar to the pattern that you notice in the A groups. You'll see the same exact pattern appear in the B groups. So group 3 will be group 3B, group 4 will be group 4B, and I'm just going to go ahead and skip over to 11. Group 11 is not going to be known as 11B, it'll just simply be known as 1B because they both end in the number 1, and group 12 will be, group 2B because they both end in the number 2. Okay. That should be simple enough. We're going to pay a lot more attention to the A groups than we will for the B groups, but still make sure you have the idea as to how to label the B groups. Then, after our groups, we organize our periodic table in terms of rows. There are 7 rows in total, or 7 periods. The main bit of information that we pull out of our rows themselves is basically how many electron shells an element is going to have. If you don't already know, you should have known from a class beforehand, you may have just forgotten, that an element is organized in a specific way. So you'd have the nucleus where all of the protons are located as well as the neutrons. And then surrounding that nucleus, you're going to have a series of shells. This is where all of the electrons are located, and you just represent them as dots. Now, you can easily count for the number of electrons by just looking at the row number. So if you're in the first period or the first row, you'd have one shell. If you go down a row, you're going to encounter elements that have two shells. If you go down another row to the third row, you're going to experience elements that have three shells, so on and so forth. Obviously, the maximum amount of shells that you can potentially have is going to be 7. And again, as you go down a period, you add an electron shell. And so an element in the first period will have one shell, an element in the second period will have two shells, so on and so forth. And now we know that our periodic table is organized in terms of groups and periods. We can also organize the periodic table in terms of types of elements. Now we're going to talk about 3 types of elements. First, we have metals, which are excellent conductors of heat and electricity and are typically solids at room temperature. In addition to this, most of your elements will fall into this category. I'll show you guys that in one bit. To contrast with the metals, you have your nonmetals, which are poor conductors of electricity and are typically going to be gases at room temperature. You'll see when looking at the periodic table that very few elements on the periodic table itself will be nonmetals. And then lastly, we have our metalloids, which are sometimes called semi-metals. These are kind of a hybrid. Some of them behave more like metals with some non-metallic properties, or some of them behave more like nonmetals with some metallic properties. In general, these are just simply hybrids of metals and nonmetals. Now here's a nice image of the periodic table organized via the metals and the nonmetals. What you probably want to do is, if you have a black and white periodic table next to you, is to pretty much copy down this line, this yellow line that you see right here. So you'd start at boron, you basically move one to the right, and you're essentially going to build a staircase all the way down to AT. If you obviously have a periodic table that includes more than AT, you just build an extra staircase down this way. Okay? Now, the reason for this is you can basically predict the properties as to how your element will behave based on this line. Any elements to the right of this line are going to behave like nonmetals, including the metalloids, and any elements to the left of this line will behave like metals. Now there's a very clear exception to this rule, that being this little guy over here, which is hydrogen. Hydrogen is the one nonmetal sitting amongst all of these metals. You just need to know that it is the one nonmetal sitting on this side. As you can tell, the metalloids, or the semi-metals, which are colored in purple, are going to behave in different ways. So germanium, Ge, and antimony, Sb, are going to be more metallic in nature when reacting with something else. And then boron, silicon, arsenic, tellurium, and acetine will behave more properly to nonmetals in a chemical reaction. Make sure that you do copy this line on your periodic table so you can easily differentiate between your metals and your nonmetals. And then lastly, in terms of organizing the periodic table, we're going to set up some element classes or families. Recall that I had stated before that groups pretty much denote elements with similar properties, so elements in the same exact column will behave similarly to each other. We're going to go ahead and specify some specific groups. So first we have the alkali metals, which are the first column, or group 1/1A. There is one exception to this rule, that being that if you look at group 1, you'll notice that hydrogen is located in the alkali metal section. We already went over the fact that hydrogen is not a metal, so it literally cannot be an alkali metal. So make sure that you write down that hydrogen is not an alkali metal. Because once again, it is literally not a metal. It is a non-metal. Immediately next to it, we have the alkaline earth metals, which are group 2 or 2A, so they would be in the second column. Then all the way across the periodic table to the second to last group is going to be the halogens, group 17 to 7A. The main halogens that we'll look at in this course are going to be fluorine, chlorine, bromine, and iodide. These are the main ones. There's obviously more elements in that column, but in general, we mainly hone in on these four specifically. Then in the last column, or the last group, we have our noble gases, which are group 18 or 8A. The main characteristic of the noble gases is that they're incredibly unreactive, so if you put them in a container with other chemicals, they're really just going to mind their own business and not do much chemical reactions. Now there is one more class or family that we're going to talk about, that being the transition metals. And if you notice, for the transition metals, it is a series of groups. So it's groups 3 through 12. So that entire middle section on the periodic table will all be your transition metals. So if you actually look on the periodic table, which I'm going to show in a second, you'll see that nearly a majority of your elements are going to be transition metals. So right here, we can clearly tell all the distinctions. So these elements colored in red in the first group are the alkali metals, obviously not including hydrogen. The elements in orange are the alkaline earth metals in group 2A. This entire middle section colored in yellow is going to be the transition metals. When we go all the way across, you can see in this kind of darkish, but not really that dark purple, the halogens in group 17 or 7A. And then lastly, the noble gases in the just straight up purple in group 18 or 8A. There's other families slash classes. So in the green, you can see that there are basic metals. In the blue, you can see the metalloids or semi-metals. In this darkish purple blue, you can see the nonmetals. And at the very bottom in brown are the lanthanides. And in this like kind of dark red are the anthanides. We don't need to pay much attention to these. The main ones that you should concern yourself with are the alkali metals, the alkaline metals, the transition metals, the halogens, and lastly, the noble gases.